So solving equations. Now, some of the students today have been struggling with this. But as I just started to tell my class, I'll re-say it. The major concept of this is if we have a bucket and the bucket has water in it and then 2 baseballs in it, would it be safe to say that we have, or the contents of the bucket is water plus 2 baseballs? What if we just wanted to have the water by itself? Remove, take away, or subtract the 2 baseballs. That's the major concept of this. So, if you were to add the same, so that's our precursor, our attention getter, I guess you could say. If you were to add the same number to each side of an equation, 2 sides would remain equal. And that is through the addition property of equality. Okay? The addition property of equality. This one here is the substitution quality of a property. It's just saying that if I were to subtract a number from both sides of an equation, it's still going to be the same thing. Because equals means the same, right? We are going to be solving equations today. Equations comes from the word equal. There's a couple things that we're going to do here. Here's an example that uses a mat, an addition mat, with a variable. We have this example. We have x plus 5 equals 8. We want to solve for x. We want to solve for the variable. And in order to do that, this is what we need to do. And I want you to write this. To solve for the variable, we must get the variable by itself. We must get the variable by itself. In order to solve for the variable, we must get the variable by itself. Because we want it to be, in this case, x equals something, so we can find out what x is. Because as we've learned in this class, variables can be anything. They can represent any number until we find out what it is. Now, in order to do that, in order to do this, we must undo what is being done. What is being done to the variable. We have to undo what's being done to the variable because we want the variable to be by itself. We must undo what's being done to the variable. And also, I'm writing really big. You don't have to write that big. Okay, that's good. Now we're going to do our trusty way to tell if this is something that I want to remember, which is, here. I'm going to highlight that information because I need to memorize this information, not just practice with the homework, but I need to remember this stuff. Yeah, I don't know, that was bad. Yes. Oh, I'm gonna send that to. Hey, this is supposed to go home to Mom last night.
I know. That's why
Okay. Make sure you don't forget again. Okay. To solve for the variable, we must get it by itself. In order to do this, we must undo what is being done to the variable. What are they talking about? Nope, not yet. In the future. We'll do. What part are you at? What is done to the variable? What is being done? Sorry. because it's a progressive, being done. So, for example, we have x plus 5. Our x is represented, whoa, buddy. Our x is being expressed with this shape here, because we don't know what x is. For this situation, it's a glass or a vase. I don't know. So we have x plus 5, because 5 is being added to it. Whatever x is, that's being added to it. Okay, you don't have to highlight those if you don't need to. I'm just trying to show YouTube what I'm pointing to, because they can't see me. I'm impressed. None of you turned around just then. That was good. So it was like, hey, YouTube. No. Do you agree that... Right. I just got my students to think there's a camera on me. So do you agree that x with 5 integers is represented by this thing here? X plus 5 integers? Yes, because here is x, and here is 5 integers. 1, 2, 3, 4, 5. And that is equal to 8, as it shows in our equation. Okay, here's this represented. There's 8 right there. Now, according to what you just highlighted, we have to undo what's happening to x. And what's happening to x? Yeah.
It's becoming 3.
No, it's not becoming 3. It already is 3, but we have to discover that yet. What's being done to x? What's being done to x? Look on your example. Nope. What's being done to x? You said taken away. What's being done to it? No. Look. What's being done to x? What's being done to x?
It's going to be added to 5.
Ah, there you go. Yes. It's not going to be added to 5. 5 is being added to it. 5 is being added to it. Now I ask you, what is the opposite of addition? Subtraction. Write that down. Subtraction is the opposite of addition. And addition is the opposite of subtraction. Do you agree? Yeah. And addition is the opposite of subtraction. Subtraction is the opposite of addition. Addition is the opposite of subtraction for those that are still writing, and that's really small. And the reason why I write that is because in order to get the opposite, these guys is how you undo what's being done to x. So if it's being added, we have to subtract. If it's being subtracted, we have to add. What that has to do with it is this. We're going to zoom into this guy right here. So here we have x plus 5 is right here. In order to get 5 to go away, we have to do the opposite of plus 5. And what is the opposite of plus 5, somebody? Yes, Dana? Minus 5. So we take x plus 5 is here. Ooh. X plus 5 is here. In order to make this x plus 5, the plus 5 go away, we subtract 5. Now, by the subtraction property of equality, we have to make sure that this equal sign stays the same. We can't make it unequal. In mathematics, things don't just happen for no reason. Or for better English, there has to be a reason for stuff to happen. This equal sign means that to be equal, this side is having something happen to it, so this side has something happen to it. Since this side is getting -5, this side has to get -5. And then we find out, just by looking at this, that 8 minus 5 equals what? 3. 8 minus 5 is 3, and x equals 3. And to demonstrate that using your mat, here it is again. We have x plus 5 minus 5. That's out of here. We have to do it to the same thing on both sides because of the subtraction property of equality that you have the definition for on top. And what are the things that are not removed from the mat? X equals 3. Good for x, all by itself, being very asocial. Not to be confused with antisocial, because antisocial is you're against society, asocial is you'd rather not be with it. Yes?
Can we just do the math and not show all that order?
It's funny that you should say that, because fourth period, someone said the exact opposite.
I just want to do the math.
We're going to do a couple examples. You might change your mind.
You want to do it live? I want to do the math.
Okay. As we look at number 1, we see something. This is the first thing we have to recognize. What is being done to the variable? It doesn't matter what side of the equal sign it's on, because 1 is equal to 1, regardless of where 1 is. Right? So, to put it in other words, it doesn't matter what side it's on, whether it's on this side or whether it's on this side. By it, I mean the variable. Because when you have 2 plus 1, 3. 2 plus 3 equals 1. Is that different than 1 equals 2 plus 3? What? Is that different than 5 equals 2 plus 3? No, it's the same thing. Yeah, it's the same thing. So, it doesn't matter what side the variable's on. What is happening to h? Jake, what's happening to h? So he said that h is having 93 added onto it. So how do we undo that? Change it to a negative. I think I know what you're thinking, but I don't know if you said it that. So you're saying that all I have to do is change that? Is that what you're saying? No. What? He said that just change the sign to a negative. Change the h to a negative h. So you're going to do more to h to make less happen to it? Because if you're changing h to a negative h, that means that what you're doing is you're multiplying h by -1. We're trying to get h by itself. You're adding more. Because that's what it says up here. We want to get the variable by itself. That's what we said in this one. We want to get the variable by itself. You're adding more to it. That's the opposite of making it more by itself. Jace?
Can you do 93 minus 93?
There we go. So, we have to make the 93 go away. And what's the opposite of plus? Subtraction. What's the opposite of addition? It's subtraction. So if we are adding 93, how do we get it to go away? Johanna? Not sure. Okay. Well, first off, what's the opposite of addition? Subtraction. What's the opposite of 93? Yeah. So we have negative 93 here. Then, because we have the subtraction rule of equality, we have to have both sides of the equal sign get manipulated like that. So now we just have h on one side, and now we just have to think, what is 71 minus 93. This was last night's homework. Stearns? Negative 22 is correct. So I'll rewrite that a couple different ways. So what we just did is we did 71 minus 93, or you could do it as being 71 plus negative 93. Or you could look at it as being 93 minus 71, and then that would all be minus 1, which becomes 22. So the opposite of 22 because of this guy, so it becomes negative carried over. But that's algebra. Okay? All that equals 22. Negative 22. Now, if you have questions on that, let's do one more example before you say, I don't get it, because there's still room. Now, we have the variable on the other side again. $12 plus p equals negative 45. What's the first thing that we think about? Getting rid of the 12. Even before we think of that, before we recognize that, we have to say, what is being done to the variable that we have to undo? What is being done to the variable? So here's our variable. What is being done to it that we need to undo? Charlie? It's being added to 12. So how do we get that alone? Take away the 12. And because we have to be equal, we have to do the same thing to this side. So negative 45 minus 12 is what, Lainey? Negative 57. Yeah. Isn't it fun? Wait, it was or was not sarcasm?
It wasn't.
Good. That's what I like to hear.
Will the next one be adding 39?
Okay. So we are going to now do number 3. I would like you to work this one out, show all your work, and we'll see how it goes.
Can I do the rest of the paper?
Here, since you seem to understand it so well, can you please run these 3 things to the office? These 2 are homework requests, and this is a cell phone from class. So you have to pick that up in the main office after school. Have you had one? Have you been caught with it yet? Okay, next time you get caught, you have to have your parents come and get it. Okay. Off and in your cell phone until after, or off and in your locker until after school. Okay, those are 9s. Okay, looks like a 5. Yes, ma'am. Yes. Question? We're doing number 3. We're just doing number 3, and then we're going to see if you got it. Then we're going to roll with it. Okay? All right. So for number 3, here's what you should have written down. Because you know that 39 is being taken away from M. And you're like, M, I'm so sorry that they took 39 away from you. Here, bro, let me help you out. Go ahead and have a 39. And because you want to be equal, because not being equal is bad, you want to add 39 to this side as well. And oh, go away. Oh, come on. We have negative 4 plus 39 is equal to positive 35. We have M equals 35. Okay? I'm going to show you how to check yourself so there's no wreckage. Okay? This is how you check yourself so there's no wreckage of oneself. This is how I check my work. Yes. This is how I check my work, or how Ice Cube would check himself so he does not wreck himself. Ice Cube is the rapper who made that song.
I like that one. I like that one song that he made. Oh, no.
Yep. Yep. Yes, sir.
So you have to switch whatever you have to take out and then put that under the next numbers?
Yes, because it has to be it has to be equal. Wait, there, my microphone's on. It has to be equal. That's why this equal sign right here is there. You have to do both to both sides. Now, here's how you check your answer. Didn't we solve for m? Right? So if we solve for m, that means that what I can do now is I can insert m back into where it was. So we have m equals 35 minus 39 equals 4. Is that the truth? Or sorry, equals negative 4. Is that the truth? Then that means you found the correct answer for m. Because do you agree that negative 4 is equal to negative 4? I sure do. Negative 4 is equal to negative 4. Okay? Because you took... Here, let's use some technology, shall we? So we have m minus 35. We know that m is equal to 30. M is equal to 35. Do you agree? Okay, so I'm going to take m as 35, replace the m with 35. 30. Ooh, boy. That was not pretty. Okay. 35 minus 39 equals negative 4. Negative 4 equals negative 4. Woohoo! 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 Okay? Put a ring on it? Number 4. I would like you... Yeah, here's what I'm going to do to you. We're going to do harder ones. Right, Smith on number 4. Right, so there's going to be harder ones next page. Right, Smith on number 5. No, it's not your homework. There's harder ones on the second page, and we're going to go through those. All right. Ah, that's why we did that last period. There they are. I do not have a dance for this. So, here's what's happening where, for some reason, when I broke people loose, I want to talk about this. For number 6, what was happening is people weren't recognizing what's happening to G. What's happening to G for number 6? What's happening to it, Harrison? 5 is being subtracted from it. So how are we going to get that to be back to being an OG, a regular G? Yeah. See, that's the same thing that other people... Yes. That's the same thing. What you first misspoke, I think you understood it. I think you just misspoke. What people are wanting to do for this one, which is wrong, they're taking away 5 more. No. If you want 5 to be by itself and somebody takes away 5, he's like, oh, here, let me help you out, buddy. I'm going to take away 5 more from you. No. You have to add 5 to get it back to being just a G. You added 5 to that side. The correct answer is 24 equals G. Because do you agree that 19 plus 5 is 24?
So would you add 12? No, you would subtract 12, right? Because it's 2 negative.
Actually, we're going to talk about that one next. Now, here's one to dance to.
No dancing.
Tell me how you really feel. Okay. Here's a situation once again. It isn't multiplication, so it's not the silly dance that I did yesterday, but it is with the additive inverse. What did the additive inverse say yesterday when we were doing it? If you change one thing, what else do you have to change? The other thing. So the other thing is changing the two signs. So if we change this sign, we have to change this sign. And the main thing is, you can do that dance where you put your arm here, a negative minus becomes positive. Sorry, I hurt my shoulder last night playing volleyball, which I rocked, by the way. I played awesome last night. But so it's a negative minus becomes a positive. Okay? Whoa. So this is rewritten. This is not simplified. There's a lot of questions on this that you need to rewrite. So it becomes Z plus 12 equals negative 7. Z plus 12 equals negative 7. If I had a son, I'd name him Evan. I would. I really like that name. My cousin's name is Evan. He's a real cool cat. No, my cousin's not a cat. He's a cool cat. It's a term of endearment. I don't know. So now we have Z plus 12. Melville, what are we going to do to make Z by itself? U. This is what's happening. Yes. Subtract 12. And because of the addition property of equality, we have to do it both sides that are equal. So we now have Z equals negative 29.
Oh, yeah.
It's
19 is correct. Thank you. Thank you. Jake, you all right? Yeah. Okay. Do you understand this well that you're fooling around? You don't even have anything written that I have written. Let's go. Good. Now, another part of the homework that which you may get a little confused upon is... Yeah, let's do number 15. Oh, this question here is just like the one that we just did, where you have to take the double additive. Okay. Let's do number 15, because I don't think that all the classes were able to do that. Let's do number 15. Now, the first thing that you have to do with this, can someone tell me what's the first thing I have to do? There's no multiplication here. Everything has a sign between it. So there's no multiplication. What's the first thing you need to do, Harrison?
You would have to rewrite the problem.
Yes. We have to rewrite the problem, or in other words, simplify it. Boy, is this complicated. I want to make it look more pretty. Okay? So what Harrison just said was, we need to take the additive inverse of those two, so it just becomes n plus 2 plus negative 3. Now, is it necessary to have those parentheses that I just put in there? Is it? No. With this guy, I'm going to leave it in there because I want to remember that that's a negative right there. However, this one here, these guys, they're just making it looking more confusing. Because there's no multiplication going on there. We don't need to use the distributive property from last week, right? We don't have to use it. So what this actually just becomes is n plus plus 2 plus negative 3. Do we have any like terms in there, Johanna? No? You sure? Do we have any like terms in there? Is there anything that can be added together so it's simpler?
Yeah.
Yes. Which ones? Can you have 2 notebooks and add the number 2 to it? No. How about can you add the number 2 and add the number negative 3 to it? Yeah. Hey, you know what? Sometimes we all need a little shove. In the right direction, not like a physical dispute kind of shove. No, don't. These two are like terms. These two are like terms. So we have 16 equals n what? Cam. Do you agree that 2 plus negative 3 is negative 1? Okay. How do we undo that negative 1 being done to n? Who haven't heard from you today? Abby, haven't heard from you today. How do I get this n to be alone? What needs to? Well, what's being done to it is we have. I hope this one erases right now. You have to add 1. So we have to add 1. Okay, let's get that. Whoops. We have to add the 1. The 1 is already being added to it. Right? So are you saying that what you did is you rewrote n like this?
But it's negative 1.
Yeah.
Additive inverse. We changed this sign. We changed that sign. I'm just going back. I'm trying to get it to match what Abby just said. Come on, erase. Is that what you're saying? Like you need to add 1 to it? Not sure. You know what? If you would like, since you're right up on, you can change your desk tomorrow to behind Owen. That way you have a better view. Cool, if you'd like. Okay. So we have an added, it's a plus sign here, which means add. What's the opposite of plus? Yes. Subtraction. So we have to get minus negative 1 to this side and minus negative 1 to this side, right? Yes, because we have to undo a negative 1 being added to it. So now we have n equals, what is 16 plus negative 1? Max. Or minus negative 1? Minus negative 1. I did. I misspoke. I'm sorry. But I have it written correctly. 17. 17 equals n, and I take my... Oh, boy. That was a lot bigger than I thought it was going to be. Okay. I circle my answer. Yeah, it is, but it got out of the way. The correct answer is 17 equals n. And, you know what? We have 5 minutes of school left. I want you to get started on the other questions on there. As I'm passing out your homework, I'm going to check and see to make sure that you're doing them correct, okay? So go ahead and get started on that. We'll make sure you're doing it correct for independent practice. I'll answer any questions that you might have as I'm going around. And the page that I'm going to be passing out is your homework. Hopefully you guys had that little help. Be sure to enjoy and watch and look at your notes and do well. Quiz Wednesday. Quiz Friday.